Okay, so if you want to follow along in your books, I am on page 68 and 69 right now. And we need to talk about the general resistance of any material. And it's defined as R equal to rho times the length of the material divided by the area. Now, more importantly, what this does for us is that we can describe the resistance of just about any material and any geometric shape of that material, even though in this case we're going to restrict that mostly to round, what we would call round stocks or square stocks, and we're going to stick mostly with copper and aluminum. So there's our general formula, but there's a few things that we need to define and take a look at before we do those calculations. One is this thing called the resistivity, or the Greek letter rho, that spelled R-H-O, and is what's known as the resistivity, or the coefficient of resistivity of a material. And you can see here that I've got figures 3.2 and table 3.1 shown there. And table 3.1 shows the resistivity of several materials. The ones that we want to focus on predominantly are silver, copper, gold, and aluminum. I'll explain why we want to talk about silver and copper in a little bit. But most of our materials that we will use are copper, most of our leads. You do see aluminum being used in different areas, but we won't get to that, talk much about that in this class, even though we will from time to time probably do a calculation where the material is resistivity. The units for resistivity, for copper, the number is 10.37, and this is a constant. Notice at 20 degrees Celsius, and it's 10.37. And notice the units. It's circular mils, cm, ohms per foot. Okay, and then of course aluminum, 9.9 circular mil, ohms per foot. Okay, and as a result, we have this unit in there called a circular mil that we need to talk about. So cm stands for circular mils. So we have to talk about mils and what those are. So let's do that here. 1 mil is equal to 1/1000th of an inch. And we'll write it in this form, 0.001. If you remember your decimals at all, that's the 10th place. This is the hundredths place, and this is the thousandths. Hopefully I'm spelling those wrong, or spelling those right. Don't hold it against me if I'm not. So 1 mil is 1/1000th of an inch. Now let's take a look at how we use this. It simplifies things, a couple of things for us. First of all, let's take a look at what this really means. So let's consider 1/4 of an inch. Well, 1/4 of an inch written in decimal would be 0.25 inches. That would equate to 250 mils, or 250 thousandths of an inch. A couple more examples. 1/3 of an inch, 0.33. Of course, that would be 0.33 repeating, but we'll just use 0.33. That would be 333 mils. To give you an example, 1/2 an inch would be 0.5 or 500 mils. 500 mils. Let's take a look at another curious one. It may look a little bit funny. Let's consider 1.5 inches. That would be 1.5 written in decimal form, or 1,500 mils, just to get that under our belt.